data types, and we have the numeric data types. We have the date and time data types, string data types, special data types, the JSON data type default values. We have data type storage requirements, choosing the right type for a column, and finally choosing data types from other database engines. MySQL supports SQL data types, and you have the definition. SQL, the structured query language that is standard for performing database operations, often divided into categories: DDL, DML, and queries. MySQL includes some additional statement categories such as replication. You can check out the chapter 9 language structure for the building blocks of SQL syntax. We have the chapter 11 data types for the data types to use for MySQL table columns, and chapter 13 SQL statement for details about SQL statements and their associated categories, and finally chapter 12 functions and operators for standard and MySQL specific functions to use and queries. So we continue here. SQL data types in several categories: numeric types, date and time types, string, character and byte types, spatial types, and the JSON data type. This chapter provides an overview and more detailed description of the properties of the types in each category and a summary of the data type storage requirements. The initial overviews are intentionally brief. Consult the more detailed descriptions for additional information about particular data types, such as the permissible formats in which you can specify values. Data type descriptions use these conventions. You have the for integer types, uppercase letter M indicates the maximum display width. For floating point and fixed point types, we have the uppercase letter M is the total number of digits that can be stored. The precision. For string types, we have the uppercase letter M is the maximum length. The maximum permissible value of the uppercase letter M depends on the data type. Uppercase letter D applies to floating point and fixed point types and indicates the number of digits following the decimal point. The scale. The maximum possible value is 30, but you should be no greater than uppercase letter N-2. FSP applies to the time, daytime, and timestamps types and represents fractional seconds per represents fractional. So F stands for fractional, S for seconds, and P for precision. So FSP stands for fractional seconds precision, that is the number of digits following the decimal point for fractional parts of seconds. The FSP value, if given, must be in the range of 0 to 6. A value of 0 signifies that there is no fractional part. If omitted, the default precision is 0. This differs from the standard SQL default of 6 for compatibility with previous MySQL versions. And then finally we have the square brackets. So here you have the square brackets indicate optional parts of type definition. So that's what we have for the chapter 11, the data types. So let's check out the next section. And what we have here is the numeric data types, and we're going to check out this concept. So we have numeric data type syntax, the integer types, exact value. We have the integer, the int, small int, tiny int, medium int, and big int or big integer. Fixed point types, exact value. We have the decimal, we have the numeric. Floating point types, approximate value, float, double. Bit value type, bit. Numeric type attributes, out of range, and overflow handling. MySQL supports all standard SQL numeric data types. These types include the exact numeric data types, integer, small integer, decimal, and numeric, as well as the approximate numeric data types, float, real, and double precision. The keyword integer is a synonym for integer. So this word here, int or just int, is a synonym for integer, and the keyword DEC, the decimal, and fixed are synonyms for decimal. So here you have dec or just decimal and fixed. MySQL treats double as a synonym for double precision, a non-standard extension. MySQL also treats real as a synonym for double precision, a non-standard variation, unless the real as float SQL mode is enabled. The bit data type stores bit values and is supported by MySQL memory, INO database, and NDB tables. For information about how SQL handles assignments, auto-range values to columns, and overflow during expression evaluation, you can check out auto-range and overflow handling. For information about storage requirements of the numeric data type, you can check out the section 11.7 data type storage requirements. For descriptions of functions that operate on numeric values, you can check out the section 12.6 numeric functions and operators. The data type used for the result of a calculation on numeric operands depends on the types of the operands and the operations performed on them. For more information, you can check out the section 12.6.1 arithmetic operators. So that's what we have for the numeric data types, and we're gonna go to the next section, and here we're gonna see a couple of examples. So let me see. Okay, so we are in numeric data type syntax. For integer data types, uppercase letter M indicates the minimum display width. The maximum display width is 255. So the maximum display width is 255. Display width is unrelated to the range of values a type can store, as described in section 11.1.6 numeric type attribute. For floating point and fixed point data types, uppercase letter M is the total number of digits that can be stored. As of MySQL 8.0.17, the display width attribute is deprecated for integer data types. You should expect support for it to be removed in future versions of MySQL. If you specify 0 field for a numeric column, MySQL automatically adds the unsigned attribute to the column. As of MySQL 8.0.17, the 0 field attribute is deprecated for numeric data types. You should expect support for it to be removed in a future version of MySQL. Consider using an alternative means of producing the effect of this attribute. For example, applications could use the LPAD or LPAD function to zero pad numbers up to the desired width, or they could store the formatted numbers in char columns. Numeric data types that permit the unsigned attribute also permit sign. However, these data types are signed by default, so the signed attribute has no effect. As of MySQL 8.0.17, the unsigned attribute is deprecated for columns of type float, double, and decimal, and any synonyms. You should expect support for it to be removed in a future version of MySQL. Consider using simple check constraint instead for such columns. Serial is an alias for big integer, unsigned, not null, auto_increment unique. Serial default value in the definition of an integer column is an alias for not null, auto_increment unique. Warning: when you use subtraction between integer values where one is of type unsigned, the result is unsigned unless no _unsigned _subtraction SQL mode is enabled. You can check out also section 12.10 class functions and operators. So here we have the bit uppercase letter M. So we have a bunch of examples here. A bit value type uppercase letter M indicates the number of bits per value from 1 to 64. The default is 1 if uppercase letter M is omitted. Here we have the tiny int or tiny integer, unsigned 0 field, a very small integer. The sign range is from negative 128 to positive 127. The unsigned range is from 0 to 255. Then we have the boolean, the boolean. These types are synonyms for tiny integers. So in the parentheses we have 1. A value of 0 is considered false. Non-zero values are considered true. So we can check out this example. So we're gonna open our terminal, and you can tell your Windows PowerShell or command prompt. So just gonna type in MySQL -u, and it's gonna be a root for my username and then my password. So I'm gonna type in my password and amen. So now I'm gonna type in select, and it's gonna be select if open close parentheses, and that with a semicolon at the end to end this statement. And inside of the parentheses we're going to have two arguments. It's going to be a 0 comma separated by separated by a comma, and we're going to have another argument, and it's going to be true inside of the single quotes, comma separated by a comma, and another argument, and this time is going to be false. So we're gonna press enter, and as you can see we have the same result, false here. So now we're gonna check out this example. So if 0, then we're gonna get true. So we're gonna type in, I'm just gonna press in my keyboard the page up. If instead of 0 we're just gonna change it to 1, so select if 1. We have three arguments, the number 1 and then the true, false. So let's press enter, and the result is 1 is true. So 0 false and 1 is true, or as they say here, a value of 0 is considered false. So 0 is considered false, and non-zero values are considered true. So this one is a non-zero, so this is the reason it's considered true. So now let's try with the number 2. Since 2 is a non-zero, we're gonna get an answer of true as well. So as you can see here, however, the values true and false are merely alias for 0 and 0, for 1 and 0 respectively, as shown here. So let's try it out. So we are gonna have in select if, okay, inside of the parentheses we have if the 0. So if the 0 is set to false, like this. If 0 is set to false, then true, then false. So let's see what we are gonna get, and let's move it to the here. Okay, so select if 0 is set to false, then we have true and false. So what we are getting is true. So 0 is being set to false, and we have the values true and false. So now we're gonna do the same thing, but this time instead of setting 0 to false, we are gonna set in 1. We're gonna set it to true. So 1 is set to true. That's okay, that is correct. So we're gonna get true. Excuse me. 0 is set to false, and 1 is set to true. That's the reason that 1 is set to true is true, and 0 is set to false is true as well. So if 0 is set to, let's try it like this. If we have 0 and we set it to true, so obviously we're gonna get false. But then again, if we have 1, we set it to false. So let's see what happens. What do you think is gonna happen? So we're gonna get false. Okay, so that's it. Now let's move on to the next example, and now we're gonna have we're gonna set in 2 to true. Okay, so 2 is gonna set to true. Okay, that's false. And okay, so true. Okay, and now we're gonna set in 2 to false. Let me see. We're gonna set in 2 to false, and it's gonna get us false. Okay, so we have that. The last two statements display the result shown because 2 is equal to neither 1 or 0. So that's the reason we get false. A small integer, so m, and unsigned 0 field, a small integer. The sign ranges from negative 32,768 to positive 32,768. The unsigned ranges from 0 to 65,535. Medium integer, unsigned 0 field. A medium signed integer. The sign ranges from negative 838,000 what is this, Okay, so this is from negative 8,388,608 to, again, it's gonna be 8,388,607. The unsigned ranges from 0 to, let me see this number, 16,777,215. So we have that. Now we have the integer unsigned zero field, a normal size integer. The sign range is from, you have this number here to this number. The unsigned range is from 0 to this whole number here, so we have that. Then we have the integer unsigned zero field. The type is a synonym for integer. Then we have the big integer unsigned zero field, a large integer. The sign range is from, well, this whooping number to this one, and the unsigned range is from 0 to this whooping number. So serial is an alias for big integer unsigned, not null, auto underscore increment unique. Some things you should be aware of with respect to big integer columns. All arithmetic is done using sign, big integer, or double values. So you should not use unsigned big integer larger than this number, 63 bits, except with bit functions. If you do that, some of the last digits in the result may be wrong because of rounding errors when comparing a big integer value to a double. MySQL can handle big integer in the following cases: when using integers to store large unsigned values in a big integer column and minimum. So we have the column underscore name, or the maximum column underscore name, where the column underscore name refers to the big integer column. Then we have when using operators, so we have the plus, the minus, and the multiplication operators, and so on, where both operands are integers. You can always store an exact integer value in a big integer column by storing it using a string. In this case, MySQL performs a string to number conversion that involves no intermediate double precision representation. The negative sign, positive sign, and the asterisk operators use the big integer arithmetic when both operands are integer values. This means that if you multiply two big integers or results from functions and return integers, you may get unexpected results when the result is larger than this number here. And let me see, we have 3, so here 6, we have a million. Then, whoa, yeah, this is a really whooping number, so we have that. And then we have the decimal unsigned, a pack exact fixed point number. The uppercase letter M is the total number of digits. The precision, and D is the number of digits after the decimal point is scaled. The decimal point and for negative numbers, the negative sign are not counted in the uppercase letter M. If the uppercase letter D is 0, values have no decimal point or fractional part. The maximum number of digits uppercase letter M is decimal is 65. The maximum number of supported decimal uppercase letter D is 30. If D is omitted, the default is 0. If the uppercase letter M is omitted, the default is 10. There is also a limit on how long the text of decimal literals can be. So you have the section 12.24.3, the expression handling, unsigned. If specified, this allows negative values, so you can check out MySQL 8.0.17. The unsigned attribute is deprecated for columns of type decimal. So we have all the basic calculations with decimal columns are done with a precision of 65 digits. We have the decimal unsigned 0, numeric unsigned. We have the float unsigned. Let me see what else. We have the float, and we also have double unsigned zero field. And finally, we have the double precision unsigned zero field, real unsigned zero field. These types are synonym for double, exception if the real underscore as underscore float SQL mode is enabled. Real is a synonym for float rather than double. So that's all the information that we have for this section, the numeric data type syntax.